Hi everyone, welcome back. This is Redox unit. I think this is lesson 4. And in this lesson we're going to be using table J with Redox. We've used table J before when we did our Penny Lab. And we learned that at the top of the table are the most active metals. If you're a metal, remember metals are losers. If you listen to heavy metal, you're a loser. So what it means up here is that if you're the most active metal, it means you lose electrons the easiest. So if you lose electrons the easiest, it means you're the most easily oxidized. For the metals. That's what it means if you're most active, okay? So lithium is very easily oxidized and more likely to exist as Li plus than it is Li. That's what that means, okay? If you're a nonmetal, if you're the most active nonmetal, remember nonmetals are gainers, okay? Nonmetals will gain electrons to become stable. So the most active nonmetal, which is fluorine, gains electron the easiest, okay? That's why it's the element's most sexiest periodic, the periodic table's most sexiest element, because it gains electrons the easiest. It attracts all the electrons. So fluorine, if you gain electrons, you're more likely to be reduced. So the things at the top of this table are more easily reduced and existing as negative ions than the things at the bottom. Okay? So we can use table J to predict if a substance will be reduced or oxidized. If you are given two metals, like here we have zinc and copper, the metal highest on the table is oxidized, right? It will be more likely to lose electrons, and the lower metal will be reduced. So if we look at this reaction, and we have zinc here, and copper ions, which is below it, zinc is higher on the table. So it will want to be oxidized. More than copper will. So it will lose electrons. And when zinc makes an ion, it makes a zinc plus 2 ion. It will lose electrons and force copper to take those 2 electrons. And so the metal that's below it will gain the electrons and turn into, solid copper. So the metal, since this is higher on table J, it will get oxidized. And gives them to copper, okay? It gets oxidized. Copper is lower, so it gets reduced and turns into the solid metal, okay? The nonmetal column is opposite. If you have 2 nonmetals, the nonmetal higher on the table is reduced. It will gain the electrons and turn into the ion, okay? It'll become a negative ion or an anion. And the lower metal will get oxidized and be the source of electrons. It'll lose electrons. Okay? So in this example, we have Br2 and iodine that we're comparing. Br is higher, so it will turn into the negative ion. It will gain the electrons. Okay? It's going to want to gain. So it's going to pull electrons from the iodine. And it will turn into the negative ion. It will turn into Br minus. And iodine will become more positive and turn into the elemental nonmetal. Okay? So we can use table J to figure out what's going to happen when you mix the solution. If you were to mix, let's say you were to mix magnesium ions with copper, okay? Since magnesium's up here and copper's way down here, see copper way down here? Magnesium wants to be de-oxidized, and the positive ion, more than copper does. So copper will not be able to lose electrons and give them to magnesium. If you were to mix these, there would be actually nothing that happened. Because magnesium wants to lose more and be the positive ion more than copper does. It's more active, okay? If you had these in a compound, so for example, if you had a very active metal like magnesium and you were reacting it with, say, copper sulfate, the more active metal can kick the less active metal out of the compound and perform a single replacement reaction. So you'd produce the magnesium with the sulfate and the copper all by itself. But a less active metal cannot do that. So if you had copper reacting with, say, magnesium nitrate, since copper is below magnesium on the table, you'd get nothing happening. And we saw this before when we did our penny lab, right? That was a redox reaction in our penny lab. Kick the hydrogen out of the zinc, kick the hydrogen out of the hydrochloric acid. Okay? So a less active metal cannot displace a more active metal. But a more active metal can displace a less active metal. Same thing with the nonmetals. So if you had fluorine and you were reacting that with KCl, the fluorine could kick out the Cl to make KF and Cl2. But if the opposite, if you had, say, Cl2 plus NaF, nothing would happen. You'd get no reaction because the Cl2 is less active. And when you react a metal with a nonmetal, it's super easy because the metal always wants to get oxidized and lose electrons, and the nonmetal always wants to get reduced and gain electrons. So the electrons will always go from the metal to the nonmetal, okay? And you'll make NaCl, right? This charge is 0, this charge is 0, this is +1, this is -1. So your metal's charge goes up, so this is oxidized, and your chlorine, your nonmetal's charge goes down, so this is reduced. This loses electrons, this guy gains them. Okay? We're going to do a demonstration tomorrow and some more practice with this. That's it for tonight's video, everybody. Have a good night, and those of you taking the AP Global tomorrow, good luck on your exam. Bye-bye.